Welcome to Ask and Learn.
So we start with a parallel plate capacitor, and we pour in a non-conducting liquid into part of the capacitor, like this. And so that what that does is it creates basically two separate capacitors in series. So I'm going to call this C1, the space without the dielectric, and this is C2 with the liquid in it. And so the equivalent capacitance of these two kind of capacitors combined into one, well, they're in series, so it's the product divided by the sum. And C1 is going to be the area times epsilon naught over, well, the dielectric is filling a fraction F, so the open space is going to be filling 1 minus F of the whole capacitor. And then C2, well, now we have a dielectric constant, so kappa times A times epsilon naught over D, and it's filling a fraction F. So if we plug these two in, this is going to be A times epsilon naught over D times 1 minus F times kappa A epsilon naught over df, and then that all over the sum of the two. So like this, and then we'll add kappa A epsilon naught. Okay, now let's simplify this a little bit. So the numerator is pretty easy. You just multiply everything out. You're going to get a squared, oh, there's a kappa in front, kappa A squared epsilon naught squared over D squared times 1 minus F times F. And then the denominator, I'll make them both have the same, both fractions in the denominator have the same denominator of their own, so D times 1 minus F times F. So this becomes A epsilon naught F over the common denominator plus kappa A epsilon naught times 1 minus F over the common denominator of B times 1 minus F times F. So now we have two fractions in a fraction, so I'll split them up into a product. This is the numerator of the whole thing, and then we'll multiply that by, let's take the reciprocal of the denominator. We can factor out an A epsilon naught times F plus kappa times 1 minus F. Okay, now an A cancels, an epsilon naught cancels, D cancels, the F and the 1 minus F here cancel, and we're left with kappa A epsilon naught over D times F plus kappa times 1 minus F. And now I can take out part of this. I can say that this is A epsilon naught over D times kappa over F plus kappa times 1 minus F. And A epsilon naught over D is the capacitance of the original capacitor, the whole thing, which is 25 microfarads. This is 25 microfarads times 6.5 over F plus 6.5 times 1 minus F. So as a function of F, we get 162.5 over F plus 6.5 times 1 minus F. Now if F is 0, well, that would mean that none of the capacitor is filled with the liquid, so we should get the original capacitance of 25 microfarads. So if F is 0, we get 162.5 over 0 plus 6.5 times 1, so 6.5, which is 25, and that is the original capacitance. And now if F is 1, that means the entire capacitor is filled with the liquid, so it should just be the original capacitance times the dielectric constant. And we get 162.5 over 1 plus 6.5 times 0, so this is just 1, which is 162.5, which is 25, the original capacitance, times 6.5, which is the dielectric constant. So this is kappa times the original capacitance.